Good afternoon. I'm absolutely delighted to welcome you to the 6th of the Royal Academy of Engineering's Innovation in a Crisis webinar series. I'm Elspeth Finch, I'm the CEO of IAND, and I'll be the chair for this afternoon's Q&A. This Innovation in a Crisis series is a single part of the Academy's response to COVID-19. The Academy has rapidly started various initiatives to leverage its expertise and networks both nationally and internationally to help solve critical challenges and assist in the public health response. The role of engineering in response to COVID is really important, and we hope this series will highlight many different ways it's contributed. This series will cover a broad range of topics, and the discussions around what panellists have learned will help feed into the Academy's policy work. Areas have looked at transporting data collection and the use of AI, as well as the work that we're looking at today to look at PPE. This is the 6th in the series, and we're delighted to have panellists willing to talk about their experiences, as well as, of course, all of you willing to listen, attend, and ask questions. We'll begin with an introduction from each of the other panellists, followed by questions I'm going to pose to each of them in turn. This will give you, the audience, a chance to submit your questions, which I'll then put on to the panellists. In order to post your questions, simply click on the Q&A feature, which is located to the bottom of your screen, and type your question into the open field. There's also a feature that allows you to upvote questions posed by other delegates, which is really helpful. So if there's a question which is similar to the one you want to raise, please just upvote it, because it means we can cover as many questions as possible during the time. I would say please don't ask questions in the chat feature, as we may not be spotted. Certainly I'm going to be looking at the Q&A feature for the questions that I need to be raising. This Q&A is about how artificial intelligence is being used to better understand how PPE can be sort of rapidly manufactured and used at scale. So I'm delighted to introduce you to today's speakers. First of all, Professor Richard Hague, Professor of Innovative Manufacturing in the University of Nottingham. Jenny Allen, who's the office manager at 4C Engineering, which is part of Project Corin. And Andy Morris, who's a North of England Operations Manager at NPL, the National Physical Laboratory. So first of all, I'd like Professor Richard Hague to say a few words.
Thanks very much, Elspeth. My name is Richard Hague. I head up the Centre for Additive Manufacturing at the University of Nottingham. And so in our normal life, we're a large research group that is looking into next generation additive manufacturing technologies, really looking at the underpinning processes, materials and computational methods for additive manufacturing, working very much with application colleagues and other scientists around the university and other organizations to really look at, I say, next generation multi-material, multifunctional additive manufacturing. So it's a big group. It's about 100 people in the research group. We're pretty well funded with EPSRC projects and industrial funding. So normally we're undertaking research looking at say, next generation additive manufacturing. We got involved with the PPE production. I think we will all have seen the lack of PPE at the beginning of the lockdown, when there was a clear lack for hospitals and healthcare workers, and we were approached by University of Nottingham Hospitals, the trust here, to see whether we could help out. There'd been a lot of interest in 3D printing of PPE. So we took a look at this, and we looked at the publicly available open source examples, and we tried a few examples out to see which ones would work, and we decided not to go down the printing them at home version. We decided to step back, take an engineering approach to look at what we could do so that we could get a regulatorily approved PPE face shield for people to use, and so in the end that was very successful. We went down a route where we use industrial additive manufacturing processes to make what we do. We use the laser sintering process and the multi-jet fusion process to make the headband, laser cut visor, laser cut band at the back, and we were able to produce in the end, well, nominally 5,000 of these headbands, but actually because we were supplying 5 visors per headband, we produced actually 25,000 visors for the local Nottingham Healthcare Trust. So very useful process, but I think the key thing for us was we went immediately down a regulatory approval route.
That's great. Thank you very much for that. Jenny, you've got obviously taken a different approach, so it'd be great to hear about your experience.
Perfect. Thank you, Elspeth. Good afternoon. I work for 4C Engineering, which we're up in Inverness. We're a really small engineering consultancy. We mostly work in wave renewable energy and also technology development on a range of other projects. For me, I'm originally a biochemist by training, so I'm not an engineer. I feel a little bit out of place here. My job title, as you'll have seen, is Office Manager, which is a generic title for dealing with all of the non-engineering problems. So talking to customers, health and safety, marketing, finance. A lot of what I do is manage the interface between the engineering and where it hits the real world. So for us, back in March at the start of COVID, it was clear that hospitals were going to be under pressure. So 4C approached the ICU department for our local hospital and asked what we could do to help. They replied they were desperately short of visors. So we kind of went, we can do that. We worked with the staff who are going to be wearing them. We worked with the hospital infection control, and we worked with Septium, who's a local medical manufacturer. And we also kind of had to work with the materials we had available. I think at that stage, a lot of people were asking the questions that we were asking, and it quickly became apparent there were sort of limited materials. So from all of that, we designed a basic visor, which we called Corin. So it took 10 days from that first email from ICU to the point where we delivered 1,000 visors. At that stage, we found that care homes were not getting any publicity and were also desperately short of PPE. So we realized we needed to ramp up production. So we worked with LifeScan, who's a bigger medical manufacturer in our area. And in the first 4 weeks of lockdown, the group supplied 3,000 visors to ICU and about 4,500 visors to local care organisations. We made the design of this open source. There's nothing complicated about it. It's a very simple design. So we don't actually know how many Corin 1 visors were made altogether, but we had people commenting from around the world. Meanwhile, during those 4 weeks of production, the engineers at 4C were doing what engineers do and saying, we've got one solution, but we think there's a better solution. So the Corin 1 was single use. It was quite labour intensive to make, and it had some design features we felt could be improved. So the engineers came up with a Corin 2, which is made from 3 pieces. 2 of them can be laser cut, and then the screen is cut from a material which was actually the roll ends from another manufacturing process and which was otherwise going to landfill. So the Corin 2 we took through CE marking, which wasn't completely straightforward, and we've had to solve some issues around it, but we've now got that on the market. For us, it's been a really big learning curve. We're not a manufacturing company, so it's a lot of new processes that we've had to work through. And we've been doing it kind of within COVID, which has meant the whole social framework that we work in has been changing as well. So that's 4C, that's what we've done. And I think back to Elspeth.
That's absolutely fantastic. Such a good introduction about the different ways that you've approached it. Andy, you've got a very different role within NPL, so it'd be great to talk about that as well.
Thanks, Elspeth. Yes, I'm Andy Morris. As mentioned by Elspeth before, I'm the operations manager for NPL North operation in Huddersfield. NPL are the National Measurement Institute for the UK. We look after standards, we look after all the national standards on behalf of the UK and all the international significance of that. We provide traceability of all measurements to our standards and then to international standards, and a whole range of measurement services and research into different measurements. It really is measurement, it's very broadly sense. My own role within Huddersfield is to run a team that is called the Manufacturing Metrology Group, and we specialise in supporting manufacturers, the clue's in the name, and in particular we look after small to medium enterprises who really need the kind of help that we offer, and that generally comprises work around dimensional metrology, dimensional measurement, surface metrology, a certain amount of work on things like XCT, and also we work on low-cost sensors for the industrial Internet of Things. And when COVID hit us, we all nearly all ended up going home. So it's virtually 1,000 people going back to their homes. There was a need, of course, to maintain critical infrastructure on behalf of the UK. So things like the MPL time signal, radiological services, all those sorts of things which we need for quality of life and to keep businesses running and so on. And since that point in time, we've slowly increased the number of people back into the laboratories and to the offices. It wasn't long after lockdown started that we started to get involved with COVID-19 related projects. Initially, it was around ventilators and the ventilator challenge with some of my colleagues in Teddington Laboratories. And then I got involved with, first of all, with a company called Protecting Heroes, which is a community interest company, who wanted to produce face visors or face shields, we call them. And it was a group of disparate people coming together to try to work out how they could do this, to do the right thing. As has been mentioned already by Jenny and Richard, they wanted to do the right thing to provide these things to the NHS. And my involvement really was to help them to understand which of the standards were most important for them to follow and how they could follow the standards which applied, and then how they could understand the testing protocols before they got these products to the notified bodies. And by doing this, we help them to shortcut the process to actually get their product out to the market. And following that, MPL actually helped to assemble and pack and dispatch these. And we have a team still doing that now. I believe we're beyond 50,000 dispatches so far. I also then went on to work with a company called Skyroar in Scotland, who normally launch rockets, which is quite an interesting departure from their normal work. And they 3D printed a face shield, and we helped them by 3D printing quite a number. I think we printed about 600 ourselves to help them. They did the rest, and then they actually assembled these items and packed them. And following on from that, I've worked with probably 30 or 40 different organizations who were keen on producing PPE or helping them to understand the quality of the PPE that's been donated to them. This is hospitals, hospital trusts, or to understand whether or not these sort of things would pass any notified body tests. It means that we've done a lot of research into different standards that apply, helped each other to help people to understand whether or not materials were suitable for the products they're manufacturing, and to interpret how they might get these new PPE products, particularly from brand new manufacturers, into the market as quickly as possible. We also identified supply chain for people and helped them to get these sorts of parts which were difficult for them to obtain. Things like PET became in very short supply early on. Elastic, amazingly, became very short supply pretty early on. And I think melt-blown, non-woven polymers, a bit of an issue now with face masks. And our current product is to look at testing. So we've been providing some unique types of tests for face masks, which provide data over and above the standard notified body test, just so that we can help people to make sure that the products they're producing at the moment will meet the standards, and to understand more about the capability of those products.
Great. Thank you so much for all three of you. I had a whole set of questions I was going to ask, and I've just changed my mind completely based on what you did. So I apologise to all three of you in advance. I think one of the things I'd like to really start with, and probably go to sort of Richard and Jenny to begin with, is really talk about the start of that process. So Jenny, I might actually start with you, because I love the way you said you had an email, and then 10 days later, you had 1,000 visors. I mean, that is incredible. Can you talk to me more about what enabled you to move at such incredible pace? What was the thing that enabled that?
I think for us, being a small company is a real advantage. Or a small group within a bigger company would do the same thing. And maybe just having the engineers who were prepared to say, everything's on the table and we need to do this. But I think it was looking back now, all sorts of things happened in those 10 days and things kept changing. And I think it was just them being able to stay fixed on this is what we're trying to achieve. And every time you find a problem, this is what we're trying to achieve. How do we work around to get to that solution? So yeah, I think small teams, group of people working together and just keeping pushing through.
And so how big was the team who were working on those 10,000 visors?
So 1,000, not 10,000.
Sorry, 1,000.
So we've got
That's a factor of 10, small thing.
We've got 4 engineers, so they did the design work. In terms of manufacturing it, we then had a lot of offers of help of companies which had either hadn't put their staff on furlough yet because it hadn't even got to that stage, but their staff were working from home. Everything was up in the air and they weren't quite sure what tasking to do. So we had maybe 5 or 6 different companies saying, please use our staff, use their time to help manufacture them. So that was a challenge in itself in terms of new rules about social distancing, new rules about different people coming in and out, trying to train up people to here's a new process. Quite often they were quite high-powered in their normal jobs, so they were coming in with their own ideas as well. But yeah, it was just so much a team effort, and we're just really grateful to everybody who got stuck in.
Can I just... Yeah, we had a slight, well, we also had a 10-day thing, but in that we didn't deliver the visors at the end of the 10 days. We got the accreditation within that 10-day period. And I think what we chose to do was actually stand back, because we were actually on it. Firstly, we wanted to supply regulatorily approved visors to the individual so they could be confident that they were safe to use. Very important for us. But also, frankly, the university was quite nervous about becoming a manufacturer. We're a university or a research group. We're not used to being actual manufacturers. And that's probably one of the biggest learning things for me, is the challenges of supply chains and what have you. So we stood back. We got a really great team together at the university, very similar to Jenny, actually, in terms of the willing collaborators and willing colleagues who were able to jump in there. We found a very quick route to regulatory approval, which would really be process is a derogation from the I think EN 166 regulation, and we were able to use the manufacturing techniques of laser cutting and additive manufacturing. We chose the powder-based additive manufacturing techniques to quickly get onto it and make some prototypes, take them down to, I mean, literally me driving down to Hemel Hempstead to get them tested twice because we failed the first time. Really interesting learning curve for me is we actually failed in our first test. And that was because of the width of the visor, and it really showed to me the importance of getting the regulatory approval here. And so we then very quickly, within a couple of days, made a wider visor, pinned it onto our headbands, took it down, got it tested, and it passed. And so very similar, I think, to Jenny, and there was lots and lots of involvement from fantastic colleagues who knew about the regulations, who knew about the manufacturing, external people who helped us with the manufacturing team. So, it was then at the point of 10 days that we got the regulatory approval, and then we scaled up to manufacture.
Yeah. And I think one of the things, just from our audience side, because I know there's quite a few questions coming through, we're going to be doing a bit of this Q&A for about another 10-15 minutes, and then I'll be going up to the questions from the floor. So, because I know there's some very good ones, I've just been checking on some of the questions that have been coming through. I mean, I think one of the things which I think is really interesting is, there's a piece around the pace that we've both been working at. And I love the fact that everybody just deals in 10-day increments. So, it's just a power of 10. But also the way that both of you are talking right from the outset about collaboration and bringing skills together at pace. And I think that's been something that's been very consistent across these other webinars. I think really now it'd be useful to talk about the regulation piece in a bit more detail. So Andy, obviously there's no way people can get regulation in 10 days unless people like yourself are enabling that to happen at real pace as well. Can you talk about how you've worked in a different way to really help basically unlock this regulation, because it's obviously so key?
I think initially the challenge was actually for organisations who hadn't done this sort of thing before, where they'd probably been making things in the past, but often very different. So the kinds of standards they're used to working with were quite different to the ones that they were now expected to follow. Yeah. So in the first instance, it was knowing that standards existed, then which standards were the appropriate ones. So it's been 166, 168 has been mentioned here, for example, for face shields. And then which parts of those standards, based on the slight change in the regulations for COVID-19, would still apply. And then, of course, the obvious things like links to notified bodies, which being an accredited calibration measurement laboratory, we kind of know people in the field. Yeah. One of the advantages of sort of working in MPL is the fact that we work with standards every day. So even though these were standards that we weren't already working with, it wasn't a great step for us to be able to interpret them, identify the aspects which are of critical importance, and to help everybody who needed our help to understand what they needed to do. And one of the things I did pretty early on was to contact the notified bodies who would ultimately do the testing on these, and to ask them where and why products were failing. And by understanding where the critical failures were, we're able to put even more emphasis on the manufacturers avoiding those failures. So a lot of it was around trying to understand what they actually meant, linking people together so they got the right kind of knowledge, a little bit of encouraging people to do some of their own modeling to model these things, just to use CAD models, for example, and some of their own simple tests, because there are certain very simple tests that people could do just to get a good feeling for whether or not these products were likely to pass or to fail.
And I think, just handing over to Jenny, that's something that you built your own testing rig on, didn't you?
We did. As Richard said, he failed his testing. We failed as well. So we were a little unclear on exactly why we'd failed. So we 3D printed the entire head and made up a testing rig to the same specifications so that we could see why it was failing, so we could then redo the design and come back again. It's still sitting in the office. It's a little disconcerting to have a head watching you.
Didn't you find it really helpful, actually? I found the failure of it really helpful in informing us what to do and where to go. And I thought it really helped us understand the regulatory process. And I think it was actually, and then it was so quick to turn it around to pass again that that I found that whole journey actually a useful thing and not scary, actually.
And I found that the notified bodies were actually, they had no problem at all in providing the kind of information that helped to understand where things might fail as well.
Yeah,
I think possibly we were further. So I think Richard got his visor through the regulation very quickly. I suspect because we produced visors first, and then it was only our second generation which went through the approval process. I think we actually then ended up there was a much bigger volume going through at that stage, and I think it took us longer to get feedback than you're talking about, which is, you know, completely understandable when they're all dealing with working from home as well and dealing with a sudden massive increase in volume.
But how long did that process take in total?
For me, or for Jenny or me?
For Jenny.
I'm trying to remember. I think probably about 3 weeks, but it all sort of blurs into one a little bit.
So, because I think one of the things for me, which is, it's really interesting speaking to the three of you, because for me it sort of busts a few myths, because people think that standards are a barrier to innovation. Whereas for me, what it seems to have done is unlock innovation. There's almost a myth that standards take a lot of time. You're saying it takes a long time, 3 weeks. That's nothing. So I think for me, it'd be really good to get your reflections on, so Richard, maybe your reflections around, you know, is actually having these CE marks and these standards something that's really unlocked innovation and enabled you to innovate as a university?
It's a double-edged sword, isn't it? I mean, you obviously have to design to the standards, and it's important to do that. But for me, it was absolutely crucial all the way through to get something that was safe for the user and that we were protected as a manufacturer. So I think that was fine. I personally didn't find it a barrier to the design or the manufacturing process. We were able to deploy the modern manufacturing, you know, laser cutting and laser-based additive manufacturing. So there was no barrier in the design. We could alter the design really quickly. It gave us a framework within which we could design and alter things. So I personally didn't find in this particular case the regulatory approval at all a barrier to what we were doing. In fact, it aided us and it really informed us in what we should be doing, actually.
So, because in some ways, having a sort of framework which you can innovate around, so the fact that there's kind of templates, there's guidance, you can then innovate around how you do it, what's the most efficient, the fastest, most sustainable way of actually building it, but it gives that framework to innovate within, rather than trying to start from scratch and just go, what should a visor be?
It does, but it is coupled with the technologies that we use. I think had we been using more traditional techniques, I think this is, then we would have been really challenged by the design, right? So you're fixed in the tool and what have you. The fact that we, additive manufacturing group, so we're going to use additive manufacturing, we were able to change the model, print it off, alter the size. It was just super quick. I mean, all of this stuff is actually really straightforward. None of the technology that we use very hard, and it's all been industrially deployed today. So it wasn't technologically very hard, but they're just very responsive, agile manufacturing techniques that in a crisis you need. Long term, if you're making hundreds of thousands of them, would you injection mold them? Of course you would. All right, but in the particular case where there was absolutely desperation from people to have these face shields, and it was just the right solution at the right time. It sounds like Jenny had the right solution at the right time. So
so what's your view on this?
Sorry, was that to me or was that to Andy?
Andy, because you're about to say something.
Yeah, I was going to say, interestingly enough, Richard's quite right. If you were going to plastic injection mold these, which you would do if you were going to produce at scale, the challenge is not to produce the hard die or the hard tools straight away, because if you get that wrong, you're in trouble. Some people went to sort of soft tooling and got the design right, and then went to hard tooling. Whereas by really looking hard at the standard, doing a lot of the testing in advance, in general, it's possible to go straight to hard tooling with the knowledge that you would only need very, very minor corrections, if at all. So that's what we try to encourage people to do when they go into large scale manufacture.
Depends how many you're going to make, though. In the end, if you're we were only going to make 5,000. We're never going to become manufacturers. So we've made it open source so other people can take these designs on. So we were never going to become manufacturers, and so having the tooling just didn't make sense. And so we just wanted to help in that particular time. So
absolutely.
So I think a couple of things that you've said, which I think for me are really interesting, which is, Jenny, I love the fact that you said, right, everything now is open source. So the fact that you're sharing, which is such a modern way of engineering, as well as I love the way that there are different approaches, there's different tools that you can use for manufacturing. I love the way that it's now open source. Anybody can use it. It's about sharing the knowledge and making sure that that's accessible. Richard, I absolutely love the way that when you're talking about the manufacturing process, it's about the right tools for the job, but without the modern methods of manufacturing, it would have been so much slower or so much more difficult. Yeah. And you probably wouldn't been able to do that job. So I love the way it's a kind of combination of existing standards, new tech, new ways of working. So could you talk a bit more about what you see as being the most innovative things that have been done during this kind of 3-4 month period? On
our particular area, I think the interesting thing for us was to use I think most people are using extrusion-based technologies, and that limits the design that you could do. So we immediately chose a technology that would give more geometric freedom to what we were doing, and then we could, be a bit robust and what have you. Everyone talks about 3D printing, or how would you 3D print this? Well, there's several different types of the process, and so you can't say it depends entirely on the process and the materials and the form of the materials and the processes to which one you can use. So I think the innovation really for me, and the most exciting thing, has been the collaboration. I say the tech was fairly straightforward. For us, it was fairly straightforward. It's our job, all right? So it wasn't hard. But the most innovative thing for me, and the most heartwarming thing, was the ability for people to come together and just go the extra mile to get things through. So I would say it was just collaboration was the thing for me.
Jenny, does that resonate with you from what you were saying earlier?
Very much the collaboration, definitely has just been phenomenal. I think almost for me as well, just the simplicity. Visor is such a simple thing that it didn't need to be complicated. But the fact that there were then probably hundreds of different groups producing their visors around the country, actually you almost get new developments and new ideas from all of those being out there, being tested, all getting feedback, all kind of interacting in those ideas as to, oh, what did you do? Oh, you did it like that. It's actually a really kind of productive breeding ground for then possibly new ideas come from all of that, everybody pushing forward and just trying things.
Andy, what about you? Because it sounds like you've been supporting a whole bunch of SMEs in terms of helping them take new products to market. So does this resonate with you about the thing that was most innovative, or what from your side do you think is the big lesson learned?
Yeah, I've been really impressed with the level of innovation that I've seen, whether it be for the sort of fastening mechanisms. I've seen every kind of fastening you could consider, or just the general design. There are so many new designs. There was a challenge on what I always call the nodding test for visors, so that when you nod your head forward like that, is it possible that you're exposing your eyes or parts of your face to somebody coughing or sneezing? And the different ways that people tackled that, either by having a much higher ocular element or having a covering here, absolutely brilliant. And the way people made them quite flexible. And currently, I can't talk about individual companies, but currently I'm working with two companies who are, a number of companies actually, using very novel materials, looking at making PPE for the future really low cost, making it recyclable, those kinds of things. It's fantastic. And people who haven't done this before, turning their hands, using the kinds of skills that they've already got in engineering, manufacturing, in science, to create something brand new, and some things that will stick with us. They'll be around for a long time, some of these things. Some of these will go beyond COVID-19.
That's hugely helpful. We've got quite a lot of questions, so I'm going to hand over to questions from the floor. There's 11 so far, but everybody, you can keep on asking them. I'm going to start with two very simple ones, which is basically just making sure that you're both pleased. The first one was from Terence Wilkins, to say he's very pleased that NPL is involved in standardisation. And certainly it wasn't something I was aware enough about, probably around your role within it. And I think it's also really good to have that visibility. So, for me, I think that is a really positive piece. There's also one, again, from Terence, around the purpose around 3D printing as rapid prototyping to get designs right before going to high volume production. And it sounds it's quite interesting. It's moved from just prototyping into small scale production, as opposed to full production. So I think it's quite interesting to see how that technology's evolved.
So if I pick up on the 3D printing one going into production, I mean, our whole raison d'etre is to take it from prototyping, which is a 90s thing, into manufacturing, which is a 21st century thing, okay? So there's millions of items being 3D printed. It's not necessarily low volume. I mean, things like in-ear hearing aids are made in their millions, dental crowns, right? So it's like it depends on the process, it depends on the design and size and geometry and all those kind of things. For these, there's a nice case study actually. Jaguar Land Rover did a PPE face shield where they, I think there's 20,000 or so, they 3D printed the headband, but then they went to mold tooling. So it can be a manufacturing method as a bridge approach. Just depends on the volume. I mean, it's in the end, it's a break-even thing and the cost effectiveness of it. And sometimes it's going to be cost effective, sometimes it's not. It depends on the complexity of the part you're making. Very, 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 very difficult to say. You can always use it, or you can't ever use it. But there's loads and loads of things being made by 3D printers.
I think we could go down a rabbit warren here, because that sounds very interesting before we even get to subtractive manufacturing. There's a question which I think is a point of clarification, which would be good to answer. Regulatory approval for clinical applications can be different to that from face coverings. Are we discussing the former or the latter, or both?
I think we've been talking about, we're not talking about publicly worn face coverings. As far as I'm aware, there are no actual standards that exist for that. And the main reason they're worn is to protect other people rather than protect the wearer at the moment. I think that it's possible that may change in the future. I'm speaking to organisations who are looking to take these sorts of products to the next level. But this is very much around PPE/medical devices.
Okay, no, that sounds helpful. One thing which, just sort of adding onto that, Jenny, because obviously you started very much within the PPE for clinical, but now your product is getting sort of pull from other settings, is that correct?
Yes. I think we're very much, we've put it on the market with a thought originally that it was just going to be care homes, NHS, but actually often now the big procurement is now kicking in for big orders for those, but we're finding small companies are now wanting to order them, not necessarily for what it was designed for. And it's well, we're clear in the instructions what processes we expect people to go through in terms of doing their own risk assessment, but actually once it's left us, we can't actually control it. We have to just accept that people will use it for what they feel is necessary. Yeah.
And I think that comes into some of the kind of questions sort of which will come to the end around what we think going forward. There's a whole bunch of technical ones here, so I might capture a couple of them. I think one of them, certainly for Andy, it's a question from someone called Charles Williams saying they're finding it very hard to get notified body approval for their PPE products because there's no exact standards for it. And the closest standards are for welding helmets, but there's not a welding helmet. So is there a route to get a new product category recognised and standard developed? So do you have any guidance around where to get started?
Yes, there are. I mean, you can contact people like BSI to sort of start that process. However, we do find that occasionally items can be covered in more than one standard. So it might well be that there is a standard that or more than one standard that applies. I have actually so far only come across one product which I was asked to look at, which I can't find a standard, and I can't find anybody who does the tests at the moment, so that's quite challenging. But that's one of the areas where we're helping to signpost people to try and help them, point them in the right direction to where either standards exist or people might know where other standards exist. And there may not even be BS standards or EN or even ISO standards. There may be ANSI standards or DIN specs, that kind of thing, VDI.
So I think there's a couple of ones which are related to that. So I'm just checking some questions. There's a question from Samuel Porticaro, who's an engineer and a meteorology professor from Peru. We've got a lot of professors online, so Richard, you're not the only professor on this call, is what I'm going to say. He's a question around what's the minimum recommended thickness medically for face shields? Must it be acrylic, or is it the kind of restriction based on the type of material, based on the thickness of material? Do you have any guidelines around that, or anything you can share?
Sorry, Richard, you go ahead.
No, I was going to say Andy's going to be better. I can say what we did. We just used PET, all right, and so it laser cut fairly thin sheets. It's about 1/2 mil thick, I think, but definitely not acrylic. But there are regulations around the optical clarity of these things, which Andy will definitely be able to tell more than me.
Yeah. There aren't any minimum specifications about the thickness of the material, but there are specifications about how robust it is. And also about the optical characteristics, as Richard said, about how clear the material is, so the transmission of light through it, or transmittance of light through it, and also how much it diffuses light, so you don't want anything with too many scratches or too many inclusions in it. And in theory, almost any material, if it's clear enough and it doesn't diffuse light, could pass. And I am looking at and have looked at some very, very interesting alternatives. PET and PETG tend to be the materials that are most used. I believe polycarbonate has been used by people as well. Under the current guidelines, with the testing that's being done just for COVID-19, some of the tests which aren't being done mean that materials that wouldn't pass the full tests, so for longer term use and for all the wide variety of uses that these things can be put to, it means that some of these other materials may pass, and that means they will be suitable for this particular application, but not for other applications.
No, that's incredibly helpful. And let's say if there's any other questions people got as follow-up questions on this, please do just put them into the chat and we will hopefully be able to cover them. There's a couple of questions which have been coming up around PPE reuse. So there's one which is Victor Castano from the National Academy of Engineering Mexico, which is, what is your technical opinion on the reuse of PPE? is it worthwhile to engineer the methods to reutilize PPE from the outset? So, you know, is there anything around PPE reuse, recycling that you can talk about? So, Richard, is there anything from your side on this?
Yeah, well, that's actually exactly what we did. So we had a view that we didn't want to, I think a lot of the 3D printed ones that are being produced were basically disposable, single use and disposable.
Yeah.
And we wanted to have something that the 3D printed, the expensive part was reusable and that if necessary, you could clip on a different frame. So with every one of our visors, we supplied a whole bunch of the clear plastic sheet that on, and it was replaceable. And so we had a view of recyclability and reusability from the get-go, because we didn't want to have a single-use item. So yeah, it's actually quite intrinsic with our design and our approach that it was reusable. Very important, I think, actually. So.
Yeah. Jenny, what about from perspective? Because you said to begin with it was much more single-use. Did that change with your second version?
That was one of the really major things between our Corin 1 and our Corin 2, is that Corin 1 was very much single use. It had a foam band across the forehead, but foam is not really disinfectable by any kind of known, any kind of hospital level procedure.
Yeah.
So it was very much had to be single use, which at the time it was like the hospital needs it, so we're happy to go with that. But as we were looking at the second generation, it's that doesn't sit comfortably with us. We would like to make it so it can be taken into its component pieces. Each of the pieces is easy to clean and can then be dried and reassembled so that it can be reused. So yeah, really important. But equally hospitals, I mean, the way hospitals work is that a lot of things are single use. And so I think it's working with the one, but keeping what we want as well, moving forward.
Yeah.
And in terms of the guidance, does the guidance have anything around how things can be cleaned, or how does that fit into the?
That's one of the biggest challenges that we've identified so far. So when if something is designed for reuse, then if it's going to be CE marked, it needs to be clear about how it should be cleaned and then how many times it could be reused. And it's part of the actual testing process when it comes to notified bodies. One of the challenges, we identify the challenges being that, first of all, it's most likely that if these have been used in a hospital environment, they will have their own standard method for cleaning items. It's often dipping things in a substance that's similar to a Milton fluid and then wiping it with Clinell wipe or something similar. And so hospitals know how to sterilize things better than any of us do. So if they have their method for sterilizing it, on cleaning these things, what effect does that have on the material? So we're most interested in material degradation. And some of the things you can see quite clearly if there's damage. So if you're wiping an ocular, a visor, with a wipe, you will see you scratched it. However, things like any elastics that's used, it's quite possible that could degrade. So we're looking at the tests that can be done to identify the level of degradation, therefore how many times you can reuse the components of PPE.
There's a kind of comment coming in that the IOM, which has done work on the reuse of PPE, and there's a report available. So it sounds like it's an area where there's quite a lot of live conversations about. There's also a follow-up conversation. So there's a question around, so we're talking, there's been a couple of feedback questions coming through from the conversation about recycling reuse. So I think we're talking about reuse first, but also what about recycling? So we've talked about reuse and making sure that in a clinical setting, it kind of works with the cleaning protocols that hospitals or care homes will have. I think there'll also be then a question if they're used in more domestic settings or other types of businesses, how to make sure that there's clear guidelines around that. Is that something that you're working on at all, Andy, as well?
Yeah, we'd looked at certainly outside the NHS, where they will have their own methods. Recognise that these things will be used elsewhere. We've suggested to anybody who is offering a reusable product that they should clearly identify what the cleaning regime is, so that you can be sure that it isn't causing degradation to the device, and also to specify any basic tests that can be undertaken by the user to make for them to know whether or not it still seems to be safe to use.
Exactly.
And as far as recycling is concerned, it's been an issue from day one, but I think we have to bear in mind that everybody started off with the whole world being extremely short of PPE, and anything was good. And we're reaching the point now where people are seriously thinking about how they might produce more recyclable products in the future.
PET is very recyclable as a material. I mean, we would do it all the time, right? So the actual visor bit, which is the bit that mainly got thrown away, it's very recyclable. And for us, the headband was fixed, right? So it's quite a reasonably sustainable product, I think. So.
And I think that the point that also, Jenny, you're making was that it wasn't fixed. You know, during the pandemic period, it wasn't that you created a visor and that was it. It was like you created one, you look to improve it. And I think that what we're talking about is the fact that the innovation of this will be continuing. Andy, from your side, there's also some questions which are coming through around, in effect, what's next, because obviously there's more and more knowledge coming through around how the virus works and how it might be changing what the regulations need to be. So how is that affecting the guidance that you do, the testing that you do, and how the regulatory environment is changing?
It's very interesting, isn't it? Because you see a lot of product on the market which talks about being antibacterial and stopping things like particles from sneezing and so on. The standards are what they are at the moment. I have no doubt that the relevant bodies who are involved with these standards will be looking at how that will change around protection from viruses. There's lots of really good ideas out there about how things can be improved and how they can be tested. Antiviral coatings, antiviral filters, these kinds of things. Also different cleaning regimes using things that we know about, like UV, ozone, a whole range of different things. But the tests that are in place, it appears at the moment, and a lot more research is needed, that they're probably mostly adequate, or possibly even 100% adequate for viruses as well as bacteria. And one of the reasons is that although viruses are much smaller than bacteria, they are generally contained in particles of liquid, which are much greater, and therefore things like filtration properties of face masks are made to stop things like coughs and sneezes. And then things like face shields, visors, it's really a line of sight type approach when it comes to that in general.
Because I think there's a note coming through from Terence Wilkins, who's a director of the Institute of Occupational Medicine, who has been focusing on this area. So he basically said, you know, he can arrange help if needed, because obviously I think this is an area when you're talking about collaboration that there are so many different organisations and types of groups who are looking at this to make sure we've got a holistic view.
Yeah, you won't be surprised to know that we're already looking at where this goes next, and the sort of next generation of testing to ensure that PPE, and particularly novel designs of PPE, can meet the standards.
I think, I'm not sure it's been covered, but I think I should have probably said that our face shield was designed to work in conjunction with a face mask, all right? So the professionals had to wear a face mask and the face shield to protect them from the coughing. So.
Great. I'm just sort of scanning a whole bunch of lists. So one of the things, and I'll come up to each of you individually afterwards, but people would like to find out if there's possibility to raise follow-up questions afterwards and contact you to make sure that we can do that. So I just wanted to make sure that I raise that question, but we'll respond afterwards. So I'm just going to answer that one. So there are a lot of questions today. So I'm quickly scanning down and trying to see if there are links. I think there's a very, there's one which is excellent stuff, well done team. So I'm just going to pass that one across to all of you so you know that it's not just difficult questions to answer. There's a question which is around collaboration, which I think is really hugely interesting. So there's someone called Casper Alothaner, and I hope I said your name correctly, from QMU in London, has been developing a visor for NHS staff, and they've got the BSI certificate recently. One of the things they're saying is it possible to coordinate activities in the area across the country in a better way? Because it seems like we've been talking about how important collaboration has been for all of you to get to this point. I suppose my question really is, how do we retain that collaboration going forward? Because obviously now the kind of immediacy of getting some face masks into hospitals has been achieved. And there was huge collaboration which got us to that point. So my question is, how do we retain that collaboration and scale it up so that we drive more impact?
Can I say, I think one of the things that seems to have worked in this process, particularly about sort of onshoring manufacturing to the UK, is the BASE PPE make team. They're pulling together mainly larger manufacturers of PPE to ensure that in the future we will have a supply, domestic supply. So I think that's possibly one of the ways of doing it.
Yeah.
And the question then has to be asked, is it about just making PPE for the COVID-19 crisis, or is it a manufacturer who wants to continue and make it beyond the crisis, beyond the current situation?
Yeah.
In which case we have to think about what other conditions apply, what other tests are required. It's a much stricter regime, mainly because PPE is intended for a whole variety of applications, not just people in healthcare environments. So it's a really good question. I would suggest that organisations like the Royal Academy are quite useful places to bring collaborators together, and other professional institutions to exist, of course. I think that's probably a very good way of doing it.
So I mean, it feels like, so with what you're saying around the sort of BASE network is, so we've got some good networks for the larger organisations. Do we need to connect? Are there opportunities for us to better connect the sort of the academic and the SME networks as well? Richard, what's your thinking around this?
Well, we try to be as open as possible, right? We try to make our designs, we created a website and put the designs there. If you could download it, and anyone that asks me a question, I respond to them and give them the designs, and they can do it. So it's always a challenge, isn't it? How you connect people who don't know each other with people who don't know each other, and that's it goes back to collaboration. I think in this particular case, no one's holding back. I don't think everyone's willing to share, and so I think that we have a nice opportunity to build on. I think Andy made a good point actually, that maybe the institutions, maybe the Royal Academy, can be a vehicle for helping that join different areas. It's very difficult for me at Nottingham to have known Jenny in Inverness, all right, but nevertheless, you happen to come across. And I don't know the need of Jenny in Inverness until we've come today, and they are the same need, right? So I think all you can really do is be as open as you possibly can and publicize. And we were lucky that we had a pretty good PR group at Nottingham who didn't do it for the PR; they did it for the getting the message out, all right? And that's the reason they did it. And so I think that's all you can do. It's very limited, all right. We had no budget for this. We had no, and so I think it's a perennial question of how you connect people, how you.
It is.
I'm
And I don't have it. I'm an academic.
I'm just really struck by the fact that we're a really small company. We've had a brilliant collaboration with other small companies around us. But like you say, Richard, you're quite a long way away. But I feel that there's just a lot of learning that we can do from already in this conversation. It's just there's so many more opportunities for innovation. There's lots of ideas. There's lots of places I want to go and look at. Well, what are they doing? Well, they've got they've done research. They've pulled information together. But we almost, as a small company, we can not necessarily even be in contact, but just pull that information in and learn and hopefully we're doing that. Sort of we're putting information out there so that other people can pick that up as well. But collaboration doesn't necessarily need to be even talking to each other. Just that exchange of information is just fabulous. Well,
you just teed me up to another question very, very perfectly. Because question, which is what assistance is there for developing countries to develop PPE locally, by Vincent Belagan. And I think one of the answers you've both been talking about is it's open source. And so I think maybe if it's possible, Vincent, for maybe to share your email address, and we can make sure that we can link you to where those open source designs are, because I think it's a very important piece. I'm just looking at timing. We've got 6 minutes to go. I'm going to try and capture one more of the upvoted ones, which is one of the questions from Victor Castano was, we've also found it's important to offer simple manuals or instructions for the general public in the correct use of PPE. What's your feelings about it? So obviously where it's being used in a clinical setting, there are a lot more rules, guidelines, and understanding around how PPE gets used. What's your thoughts around how PPE and things like the face shields get used by the general public?
I think for us, we had quite long discussions about the instructions which should go with the visors, because obviously it needs to meet the standards, so it has to be it's quite specific about what information should be in there, but also very much I'm writing it from but I want people to understand it. So we spent really quite a lot of time just, actually that picture's not clear enough. Surprisingly difficult to photograph visors as well, but just making sure that the information we're putting out there meets the standard, has the clinical requirements, but also can be understood by, I would count myself as a non-technician, not a non-specialist. I want to be able to understand it, and I want other people to understand it too.
Jenny, I'd love to share. I'd love to get a copy of your instructions. It'd be really great to see, what the comparison between the two actually. So we also had instructions, but I'd love to see how they match up. You're right; it's difficult to take photographs.
I think there's also a difference between sort of the kind of PPE you might see worn in a supermarket, for example, or the face coverings, public worn face coverings, which aren't meant to be PPE, and the government guidance is sort of fairly clear about what could constitute a face covering. They perhaps don't need so much instruction, other than please have it above your nose, because a lot of people seem to have them down here for some reason. I don't know why.
I see a lot of people wearing them on the chin, which I don't know if
yes.
it's
yes.
Just in terms of coming into the kind of closing remarks, because, thank you so much. There's still 14 open questions, and this is the third of these sessions I've done. And can I just say thank you to everybody who's been asking questions. We've never had so many. Normally there's only about 1 or 2 at the end, but this has spurred a huge amount more conversation. In order to kind of close out, so Richard, Jenny and Andy, I'd love to get some just final reflections from you around what you're planning on taking forward from this experience. So what have you learned from it? And what are your recommendations for what should happen next? So Richard, I'm going to be mean and start with you.
Well, there you go. So I started first, and then I realised that Jenny and Andy did much better introductions than me. So I'm expecting things to happen here. So I think the main thing that I got out of this as somebody who's, I'm pretty industrially connected. I work in manufacturing. I consider myself, pretty experienced in terms of my subject area, and not in an ivory tower. But I did find the experience of actually making something and delivering it, and packaging it up and delivering it, and making sure that it was a safe product, and the CE certification side of things. I did find that a really, really interesting process. I think I should take much more into my own life and work. We're not going to become manufacturers of PPE. It was never the thing that we were going to be, but we are capable of doing it, and which is why we did it. All right. And it was the right thing to do at the time. But I've taken a lot of learning. It's connected me with colleagues at the university, not just people who from external at BSI. It's already really connected me with individuals to work. Who's the right person to get us through the BSI approval? Who is the right person to get the connections into the healthcare organisations? And I think so. I think it's. I've always been up for collaboration, and I think it's a really good thing. But it's really collaborating beyond technical disciplines, I think, has been really useful here for me. And so the engineering side of stuff was fairly straightforward. We're engineers; you just get your way through it, all right? But the non-engineering discipline communication was very, very useful for me, I think.
I love it. Jenny, what about from your side? What's the thing that you've learned from this, and what's sort of next for the work that you do?
I think at 4C we've talked about designing and developing our own product before, and we've sort of started it a little bit, but it's never really got beyond the initial stages. So it was ambitious to go for a full design, development, production and second generation product in about 6 weeks. But I think we've shown that we can do it and we can move quickly when we can see the end goal. I think also the learning about collaboration, we've had so much help from different companies and different people. We couldn't have done it without their support, but that's brilliant. And I think the other thing we've learned is that we've made lots of mistakes. Sometimes you just have to go for it. You have to take the leap and just see where it leads, because it doesn't always work out. You hit problems. But I'm really hoping that we can use the learning and we can use the connections that we've made kind of as a platform for future innovation.
I love it. Andy, what about from your perspective?
Well, I'd like to say I was surprised at the sort of ingenuity that's been forthcoming from SME manufacturers in particular, but I'm not, because I've worked with SMEs a lot and they are the most amazing people. They have to be agile and they have to be able to change what they're doing quite quickly. So, but that always and continues to impress me. Collaboration, absolutely, and everything that these guys have said before me, it goes for me. Interestingly enough, one of the areas that we did collaborate, I run a small network called the MPL Manufacturer Measurement Network. Mm-hmm. And within that network, we were able to find partners for people to work together and collaborate for the first time. So that was fantastic. I'm really interested in where we go from here. So the idea of onshoring and getting a domestic PPE and medical device capability is fantastic, and it's happening. And some of the amazing ideas that are coming out from designers and manufacturers now for the use of brand new materials, brand new filters, which then results in people like myself and NPL who have to come up with even more novel types of tests, and then it puts the onus on people to create new standards for these things. But I think we've got a really good future. All these horrible things that have happened to us during the COVID-19 crisis will lead to something good in the future. A good domestic supply chain with some really, really good and even better products than we've had before.
I don't really know how I can collate all the comments and finish on a better note than that. I think the one thing I was just going to say to kind of close out is, I think for me, one of the things that's come from everything all three of you said is, for me, it feels like I've busted a whole bunch of myths around innovation in engineering. So for me, the speed at which you can get accreditation is incredible. The fact that we can innovate at such scale, that small companies can deliver huge volumes of PPE to kite marks quickly. The fact that we can collaborate at scale fast. It's all things that we know that we do, but it's made them really visible and made them really accessible, I think. So for me, I think it's very exciting the way that the industry has come together and responded, and actually gone beyond our traditional colleagues and really working cross-sector to solve some very, very large challenges. I think the clarity of the problem needs to be solved. Actually, the clarity of the regulation in terms of what's actually needed has actually helped during this period, which I think is something really useful for us to remember going forward as well. I think for me, what is most exciting is actually the collaboration piece, because we talk about it, we say collaboration is so important for innovation, that it's so important to engineering. And I think this is just proof again and again how that it's not just a talking point, it's something that actually does deliver value. Just in terms of then a few thank yous. So thank you obviously to Richard, Jenny and Andy. I really appreciate all your time, and also for being so candid about what didn't work as well as what has worked. Just for the audience, we're also intending to confirm the details of the next session shortly, and we'll be able to update you. You'll also receive a sign up link to the next event with a follow-up email where you can provide feedback for this, but also sign up for the next one. If you've got any additional questions, please just do raise them. We'll try to respond to them after this session. And just a final thank you to all of you for taking the time to listen to us today. and also to raise an enormous volume of questions, which have been quite difficult to filter, but are exceedingly valuable, and we hope that we'll be able to share them shortly too. So thank you once again, and we will just say goodbye for today.